So in this first question, we're told that Helen believes the random variable C represents cloud cover from the large data set, and it can be modeled by a discrete uniform distribution. From the large data set, we know that cloud cover is measured in octars, and we know that octars can go from 0 to 8. So that actually means that there are 9 different values that a measurement of octars can take, starting with the 0 all the way through to the 8. And since this is a discrete uniform distribution, each of them have the same probability of occurring. So for 9 values with a uniform probability of occurring, the probability is going to be 1/9 for each of them. So here we just had to be sensibly aware of the measure of octars and also what a discrete uniform distribution was. Uniform meaning they each have the same probability of occurring. In part B, we're asked to use this model to make a prediction that the probability that cloud cover is less than 50%. Well, 8 octars is 100% cloud cover, so 4 octars will be 50% cloud cover. The probability that we're going to be less than 4 is going to be 4 of these 9ths. It's the probability of 0 all the way through to the probability of 3, so 4/9. Okay, so next we're told that Helen used all of the data in the large data set for Hearn in 2015 and found that the proportion of days with cloud cover less than 50% was 0.315. And we want to comment on the suitability of Helen's model. Okay, so since the real value was less than the value that Helen gets from her model, so since 0.315 is less than 0.44, it's not a good model. It doesn't match. It doesn't help us to make predictions in a sensible way. It's significantly less or significantly different to her model. So we assume and we say it's not a good model. In part D, we're asked to suggest an appropriate refinement to Helen's model. Well, there's not much that we can say to recommend, but we can say what's wrong with the model she's using. She's used a uniform model. Each of these levels of cloud cover have the same probability, which doesn't really match the real situation. So a non-uniform distribution would be the way to go, where we're more likely to have some cloud cover than none or than full cloud cover.